Staging separates incoming lots before inspection, so traceability begins before any fruit enters the process line. Inbound weight confirms delivered quantity and anchors the lot record before quality release. Lot labels prevent mix-ups when multiple deliveries share the same receiving hall.
Opening the top layer allows inspectors to assess fruit condition without releasing the full lot into production.
Fruit temperature indicates transport control and helps predict microbial risk and processing behavior.
Immediate recording keeps acceptance criteria tied to the correct lot and reduces release errors. pH is a critical raw characteristic because it affects flavor balance and thermal process design later in the line.
The pH result is confirmed on the tablet and linked to the lot code.
Defect grading estimates usable yield and signals whether trimming losses may become excessive downstream. Quarantine prevents doubtful fruit from entering the process until QA makes a documented disposition. Only after documents and tests align is the lot released to move from receiving into raw preparation. Controlled transfer routes released fruit into the wet handling area without crossing rejected or outbound traffic. Gentle dumping limits bruising and preserves pulp quality before washing and sorting. Primary washing loosens soil and reduces incoming contamination before final rinse and inspection. Improves soil release on irregular fruit surfaces without the bruising risk of rough mechanical handling.
Intermediate rinsing removes suspended dirt, so the sanitizer stage contact cleaner fruit surfaces.
Controlled drainage prevents dirty rinse water from pooling around cleaned fruit or splashing back onto the line before fruit enters the contact section.
The sanitizer step lowers surface microbial load before inspection and cutting begin.
As the fruit travels through the tunnel, the operator confirms the sanitizer contact time before it reaches the final rinse.
A final potable rinse clears residual sanitizer and prepares the fruit for visual inspection and trimming.
Dewatering reduces carryover into inspection and helps operators see defects and contamination more clearly.
Proper spacing gives both people and sensors a clear view of each fruit before defects move deeper into the process.
Manual inspection catches obvious defects that would lower yield or compromise downstream hygiene.
Set optical sort recipe.
Controlled transfer maintains fruit integrity and prevents cleaned product from contacting rejected material zones.
Present fruit for trimming.
Opening the fruit is the first step that exposes the edible interior, so controlled handling and clean tools are essential.
Removing large seeds before mechanical extraction protects downstream equipment and lowers hard contamination risk. Edible stream enclosed and direct limits exposure once the fruit interior is open. Physical separation keeps byproduct valuable while preventing it from crossing back into the edible puree route.
Metered feeding keeps the grinder loaded evenly, so downstream pulping stays stable and efficient.
Size reduction creates a uniform mash that the pulper can process more efficiently while preserving edible yield. A balance hopper smooths feed variation, so the pulper receives a steady mash flow. Controlled pulper feed protects texture and keeps extraction conditions stable from minute to minute.
Pulping separates soft edible material from tougher fragments, improving consistency before fine finishing.
Enclosed transfer reduces exposure once the edible stream becomes a fully wet pulp. Short buffering helps the finisher run smoothly and prevents surges that can upset screen performance.
Pressure is holding steady at 15 psi.
Good. Let's keep the flow rate consistent for the Soursop.
Fine finishing improves mouthfeel while removing coarse fibrous residues that would reduce puree uniformity.
Coarse retained fiber joins the locked byproduct stream, keeping edible puree and fiber handling fully separate. Once refined, the puree moves in closed piping to protect hygiene and preserve a consistent texture. Inline fine screening catches residual particles that could affect finish quality or downstream filling performance. Segregating fine rejects protects puree quality and keeps non-edible residues out of the finished stream.
Deaeration works better when the puree arrives evenly and without surges from upstream screening.
Removing trapped air improves color stability, pump behavior, and thermal treatment consistency later on. Controlled gas removal reduces foaming and helps the puree fill and heat more predictably downstream. Closed transfer maintains the benefit of deaeration by limiting renewed air pickup before heating.
Buffering decouples extraction from later heat treatment, so the line can stay stable through short process variations.
In-process sampling checks whether the extracted puree is on track before standardization and final.
Drying stabilizes the fiber so it can be milled and bagged without spoilage risk.
Milling converts the dried fibrous material into a more uniform powder for secondary product use. Sifting improves particle uniformity and keeps the byproduct specification consistent for storage and sale. Immediate bagging protects the dry byproduct from ambient moisture pickup after drying and milling.
Formation helps the line hold the intended puree specification before heat treatment locks the batch forward.
Adjusted by blending with concentrate, which keeps the process within legal and technical control.
Thorough mixing ensures the corrected puree is uniform before it reaches the thermal CCP.
Once standardized, the puree moves to validated heating, where time and temperature become the critical control point.
A stable feed level helps the pasteurizer hold consistent flow, which is essential for valid time-temperature control.
Proceed toward aseptic handling. Controlled cooling protects quality and aligns the puree with the aseptic filler's operating conditions without reopening the system.
Post-heat sampling supports verification that the thermal step and downstream sterile handling remain under control.
CIP verification proves clean circuits are fit for service, which is essential when sterile product lines must not rely on visual assumptions alone.
Normal line release links sanitation, heat treatment evidence, and operator control before product crosses into aseptic holding.
Release confirmed.
The aseptic surge tank buffers sterile project flow, so filling remains steady without reopening the system. Stable surge tank level helps the filler run smoothly and reduces sterile interface disturbances.
Liner seal protects sterility after the product leaves the enclosed filler head.
The outer drum closure protects the sterile inner package during warehouse handling and shipment.
Traceability coating links each finished drum back to the receiving lot, tests, and CCP records. Rec weighing confirms fill consistency and helps catch underfill or overfill before shipment.
Automated vision inspection checks closure integrity and traceability details without reopening the sterile package.
Final foreign body control is placed at the packaged stage, where it is physically logical and least disruptive to the wet process.